Hey everybody, wanted to make a video about the answers for our second learning check. So this is for our Unit 8 Learning Target Check number 2. And our first question asked about using the equilibrium constant to calculate the concentration of one of the substances here. So we have our balanced equation, which we are going to use to set up our equilibrium constant formula. But before we can do that, we have to be able to know the concentrations of these substances first. So it says that there's 0.6 moles of SO2 and 0.6 moles of O2 in a 4-liter flask. So I'm going to go ahead and say for SO2, I'm going to find the molarity of SO2 by taking moles divided by liters. So the concentration of SO2 would end up being 0.150 molar. O2 is going to be the same, 0.150 molar. And then for SO3, that's actually what I'm trying to solve for. So for this one, it's a little bit of working backwards, and it's given, the KEQ is given as 680. So when I'm setting up my equilibrium constant, I know equilibrium constant is equal to 680. And then whatever my products are, I put on the top. So I need the concentration of SO3. It is squared because there's a 2 as a coefficient here. So I would make that squared. And then the bottom of this comes from the concentration of my reactants. So I have 2 SO2 here. So I plug in the concentration of SO2. It is squared because I have a 2 there. And then my concentration of O2 is 0.150 molar 2. So I'm left with SO3 being my unknown substance, or what I'm trying to solve for. So now I'm just going to use a little bit of algebra. And I'm going to take this whole bottom part and multiply it together. And then I'm going to multiply it by 680 so that I'm ending up with the concentration of SO3 squared is equal to 2.295. When I multiply these and then multiply by 680, I get 2.295. And then I just want SO3 by itself. I want to know the concentration of that. So since it is squared, the way I get rid of a square is I take the square root. So I'll take the square root of both sides. The square root of 2.295 is equal to 1.15, which would be the concentration of SO3. So that one's a little bit different, maybe because we have to work a little bit in reverse, trying to solve for one of the substance's concentration. The rest of the learning target check is about Le Chatelier's principle and calculating shifts in equilibrium. So the rest of the learning target check uses this entire equation here, and it asks about adding things or removing things. So this one, what happens to the reaction when some H2 is removed? So removing substances would lower the concentration, and when you lower the concentration, the equilibrium is going to shift towards the thing that you removed. So removing H2 in this would make this shift to the right or in the forward direction. The next one asks, what would happen to the amount of hydrogen gas if carbon monoxide was added to the reaction? So if we add something to the reaction, we're going to raise the concentration. Raising the concentration would make us shift away from whatever we rose. So carbon monoxide is over here, meaning we would shift away from carbon monoxide. And the reaction would shift to the right or in the forward direction. And if this is happening in the forward direction, that means that these are going to be my products and I'm going to make more of them. So hydrogen is going to be, more hydrogen would be produced if I added more carbon monoxide. Flipping over here, this one asks about adding, what would happen to the amount of water if we added heat? So our heat is right here in the equation. It's this 512 kilocalories. If I raise the heat, that's just like adding adding a substance. So when we add, or when we raise concentration, we shift away. So we would shift away from the temperature increase. This would shift to the left, which would mean the reverse reaction is happening at a quicker rate, which would raise the amount of water produced. So the amount of water would increase. Number 4, which way would equilibrium shift if pressure is increased? Going back to my equation, pressure is going to affect equilibrium if there's different amounts of moles on the side. So right here on this left side I have 2 moles of gas, and on the right side I have 2 moles of gas. So since I have 2 moles on each side, changing the pressure would not affect this equilibrium at all. So there would be no shift, no change to equilibrium. And then the last question on here is a little bit tricky because it asks if it's endothermic or exothermic. If you're looking at the forward reaction this way, heat is a product, so that is exothermic. If you're looking at the reverse reaction, which is this way, heat would be a reactant, which would make it endothermic. So for that one, sorry for all the flipping back and forth, but the forward reaction is exothermic and the reverse would be endothermic. So I sent you guys emails with little critiques, or like this is what you would score on the learning target check. So I just wanted to send this along with it so that you could check your work.